You've heard the term before, voltage. We're going to try and put that into physical meaning with the other terms that we've used to describe charged particle behavior. To do so, like before, I'm starting off with two charges, and I know if these two are two positive charges, capital Q and little q, I have a force between them. Both of these are feeling force F, and it can be defined as that electric force. And I really want to focus on this point in space. So in previous videos I showed you guys that there's this electric field that's defined as the force per charge. So it's defining something about that particular point in space, and that is just kq over r squared, because the little q is taken out from the division of little q. So that space has an electric field equal to this value. And I'm going to use, well, let me just define this again. This is the force per charge, and it describes the effect from positive Q. Something happens here because of capital Q. This describes the effect from capital Q. Okay, so this same train of thinking can be applied to potential energy per a given charge. So use the same thinking. And we're going to define this new term as voltage. And it's going to be the potential energy per a given charge. The potential energy per a given charge. So it also describes something about this point in space that is irrelevant of the actual charge there. It's only going to speak to the effect from this capital Q charge. So for point charges, that's all we're looking at thus far. For point charges, we have the voltage as UE over test charge, and this would be K capital Q little q over R. That's my potential energy due to two charges, but all of that is over the little q test charge. And these two cancel out, and I'm left with kq over R. And that is my voltage. So what does that mean? Well, voltage is a property of space surrounding the charge. So because this charge is here, space is different. And voltage is a property of space surrounding the charge, or charges. It tells you how much potential energy is in any given charge. It tells you how much potential energy, I'm going to use PE for short, is in any given charge. The measurement for this, V is called voltage, but it's measured, I misspelled it, measured in volts. Well, what is a volt? And we could put this together. We see that it's potential energy over charge. What's our unit for potential energy? That's a joule over coulomb. So volt, 1 volt is 1 joule over coulomb. And this means that if I say have a battery here with a positive and a negative terminal. Positive, negative. For every charge that goes through my battery, that particle gains 1 joule of energy. So for every charge, for every coulomb of charge, C, that moves through the battery, that charge will gain 1 joule of energy. Okay. That's it for now for voltage. See you soon.